So welcome. This is Ryan's first exhibition, and this is a crucial part of what we're building in the middle school here. Saul is a big veteran, and Lev is a semi-veteran. This will be Lev's second round, and Saul, which is Saul's third round. But in an exhibition, what we're expected to do is to take something that you've learned and not only present on it, but to teach it to an assembled group of adults and fellow students. You have a sheet in front of you asking some questions about how Ryan does. That sheet is optional for you. If you feel like making some notes, that's great. If you don't, there's no need. But this is the basic rubric that I'm using. So as I'm tic-tacking on the computer, I'm making some notes, and Ryan and I will talk about those even after the exhibition goes. The basic question I'm asking, the basic two questions are, how well does Ryan know this material? And how well do I know it now that I've had half an hour of time with Ryan working on it? How well does he know it? How well do he know it? So thank you very much for coming. Appreciate it very much. And Ryan, this show is now yours. I'll keep track of time for you, but other than that, gone.
Okay, so today for this first presentation, I'm going to be talking about game theory. What is game theory? Game theory is, to say in fancy words, it is the study of mathematical models of conflict and cooperation between intelligent, rational decision makers. In other words, it is how to make decisions and how to judge others' decisions and how to respond to them. Today,
Sorry, are these extras?
Today I'm bringing multiple games, different examples of games to show you. I have three games: Prisoner's Dilemma, Two Sides of the Toilet, and the $100 Launch. In Prisoner's Dilemma, and you can look on your first page that I handed out. Here you have two prisoners, partners in crime. They each have two options: confess or don't confess. Here's the catch. Neither of the prisoners can communicate with each other, and they will make their choice simultaneously at the same time, which means they cannot base their choice off the other prisoner's choice. If you look, we have a graph. You can see all the choices that prisoner 1 can do, and all the choices prisoner 2 can do, and the outcome they will have. Now, the number in the outcome represents the number of years they will serve. As you can see, if both prisoners confess, both do 5 years in prison. If prisoner 1, say, confesses and prisoner 2 stays silent, then prisoner 1 gets rewarded for being a snitch and takes off, while prisoner U serves 15 years in prison. This can also be reversed, with prisoner 2 confessing and taking off, and prisoner 1 being locked up for 15 years. In the end, if neither prisoner confesses, they each serve only 1 year, and then hopefully go. Now, if we add up the years in jail, if you confess, though most people generally will not, then you'll either get 15 years if the other player confesses, or no time at all when the other player stays silent. On the other hand, if you stay silent, then you get either 1 year when the other player stays silent, or 15 years if the other player confesses. So generally, with the numbers, it would be best confessing, but in the end, it is up to these unfortunate prisoners to decide for themselves.
So you say better options.
Graph numbers.
Yeah, graph. So you say you recommend confessing because you either get 5 or 0. How do you make the decision that that's better than either 1 or 15?
Essentially, I just based it down to numbers. Just added up the numbers on each side. I just based them off each other. You have the chance. So essentially, if there's a 50-50 chance that the other person
innocent. It's just I know that I'm guilty. My only decision is whether to admit it or not.
Not necessarily, because as we all know, sadly, sometimes innocent people go to prison. So even if, say, player one doesn't confess and player two confesses, even if player one was innocent, with the confession of player two is just the rat who says, no, he really did it, and he actually did it, and with that type of testimony, player one would probably go to jail.
So confession is not necessarily I did it. It can be he did it. So it's not really.
It's more of a we did it, because if you sink yourself, then like you get like sometimes how the police work is like policemen will try to make a deal like you take off 5 years off my sentence, and I'll give up this other guy in the game who also did something bad, so you can catch them.
So,
Thank you. It's just it really helps.
I've seen in quite a different versions of great example. Two of the questions, one little one actually was if you change the word confess to snitch, how do you think that impacts your life?
Snitch is definitely a harsher word, and less people wouldn't want to do that because it's kind of bad to be seen as a snitch.
Can you snitch on yourself?
Yeah, I think so, yes.
But snitching, the implication is really that you're talking about somebody else. Confessing is talking about your own experience. Snitching is turning someone else in. It's pretty considered behind the curtain. So I agree with you that would reduce the likelihood. Another question is, what is the way you explain the objections from people and guilty?
Well, essentially, the objective would be to try to stay out of jail, and if you get in jail, try to get out as soon as possible.
And if you change the objective, you want to minimize the impact on everyone who is involved in the crime, how would that change the outcome?
Then you would have to analyze what happens when the other person on the other person's side. So here, as you can see, you would want to not confess because then there's a 0 or 1, depending on if they confess or not. And then they get a 5 or 15 if you confess. So if you're trying to help yourself, confess. If you're trying to help the other person, don't confess. Now here we essentially have a sub-game, just another way of seeing it. You have two cowboys, or ragers, or whatever you want to say. You just found a pot of gold. And as you two go to bed, you ask yourself, do you want to wait till morning to split the gold, or do you want to run off into the night with the gold? If you split, it'd be good. But if you wait, then there's the chance that your so-called partner will run off with the gold. If you both split, then the gold is 50-50. If you split and he runs away with the gold, then he gets the entire part of gold, 100%, and you get nothing. And if he splits and you steal the gold, then you get 100% of it, and he gets nothing. But if you both decide to get up in the night, then you just kill each other and deal with it.
And no one gets the gold.
So essentially here, even though it would seem like the worst idea and not being good, running away with the gold would be best, because then you either have nothing or 100, as opposed to nothing or 50.
So you're saying that you either having all the gold or essentially being dead is better than the other guy getting all the other gold.
Let's change the being dead to, let's say, gold fell down into a giant canyon where no one finds it.
I see. So you don't want the other
Basically,
guy to have gold.
if both people get up, everyone loses the gold and there's no gold. So if both people get up, then it's just 0 to 0.
Oh well.
Now our second subject is jump or don't jump. You see a man drowning in a river. It's a fast river, it's dangerous, and fell in. Now, would you jump in to save him, or do you wait for someone else? Now here we have our 4 ways to go. Now, if everyone else jumps in, then you're all fine. Just you jumped in, everyone jumped in, the guy's saved, and we're all just running around. Fine. If only you jump in, then you save him, and everyone else is fine. If then you start drowning in the river, only they jump in. And when I mean they, I don't mean like a crowd. I mean just another person. And that person jumps in, then you were fine sitting by the side, but then they're drowning. And if no one jumps in, then that poor fellow in the river drowns.
So you might want to do option 1.
But how can you count on that the other guy will jump in?
You get a few people to say.
Toss him in and then jump in after him.
No, jump. Okay, let's see this guy. Wait, what? But now I have 2 people.
Alright, so now we have our second game. 2/3 of the total. We have, let's say, 1,000 people, random people all across the world. They just got picked by phone, email, and each person submits a number. The person who picks the number closest to third numbers, like the median issue, gets a prize. Millions of dollars, fancy car, vacation to the Caribbean, something like that. And the range of numbers is from 1 to 1,000, including 0. Now you would think that just go for 666 or 2/3 of 1,000. But then you have to realize, if everyone picks at that 2/3 mark, then it is no longer the 2/3 mark. And it has just lowered the 2/3 mark. So then you will lower your choice. But then you have to think, will everyone else realize that? Or will everyone else realize that? Eventually, if this pattern continues, you'll go mad. That too, but the person who wins will most likely be the person closest to 0.
You know, I'm sorry to be the one who picks on you, as your mom, but 2/3 of the average is actually 333, not 667, because if all the people pick any number between 0 and 1,000, the average of all the numbers they pick would be 500. Now, if you want to pick 2/3 of the average, you need to pick 333.
Like the 2/3 mark of
The average, right? But these people can be free to choose. It doesn't affect your game theory idea at all. It's just a small oversight I think you had. Sorry for me to tell you that. I'll give you high marks on these evaluation sheets. But the idea is that it is not effective.
Now you may think these are just little games, petty theft, people running around, but it can be used like in the many world matters, in international communication. Like it can affect nuclear war. Remember our prisoners. What if the prisoner wanted to, or the country wanted to? And what if they got the nuclear missile? Now, if we go back to that graph, we could say confess equals launch. Don't confess equals don't launch. You don't launch, they launch, you get wiped out. You both launch, you both wiped out. Neither of you launch, it's best. So you want to confess.
After the 5 and 5, there's a between and there, and then 1 and 1. So essentially, the only desirable outcome is the very bottom one. The one,
No.
there's 1 and 1 in this.
The one where you confess and the other one no.
But then one of them is wiped out.
Yeah,
But then you want the whole world to be alive.
Ryan, this is the heart of my lab question. That if you have a different understanding of the Because we've been playing this game since 1925. And we've chosen, everyone has chosen the fourth option every time.
But what if one day this happened? Or this happened?
Yeah, and they're, all eat
I don't feel so good.
I don't like mushrooms.
Well, they're back there. They're radioactive mushrooms.
They're right
the
there.
life size radioactive mushrooms.
Right there.
Right there.
So I guess one, following up on Carl's, one thing is, keep the stake high enough, right? So that, everybody has something to lose if they, in this case, if they can confess. Or if they launch.
It's
So,
actually very rare in nuclear warfare that either the second or third options will actually happen, because nukes are not actually instant, like a word might be.
right.
Like, people will have like a 90-minute delay, missile incoming. We'll fire our own missiles. So it's very likely that if one person fires a missile, the second person. So currently we have option 4, but if some guy goes crazy, some mad weirdo takes control of a superpower, then this is what's gonna happen.
Yeah,
Right.
that's mutually assured destruction. That is the point of making sure everyone knows what you
So
basically,
basically, in that situation, you only have two choices, the LL and BB, right? Because the middle, yeah, exactly.
middle ones won't last.
Right, it'll last for.
And no one has been, for all our talk of rogue states, and, no one has been crazy enough to set off the first. But 15 minutes.
Oh shoot. The background.
But I'm ready to later.
Alright, so this was a much harder topic. It was really hard to even begin to grasp. But I will try as best I can to explain something. So now, astrophysics is a branch of astronomy which studies the origin and composition of the universe, and basically studies the universe, how it's made, how it works, and stuff. Now, the modern study, I mean, of course, people are staring at the stars since people existed, but the modern study of astrophysics first began in 1905, when Albert Einstein published 3 papers which both established him as one of the world's leading scientists and started 2 conceptual revolutions which changed our understanding of time, space, and reality itself. Now, toward the end of the 19th century, which was the 1800s, scientists imagined that space was filled with a continuous medium, which they called ether. Light and radio waves were just waves in this ether. Now, if you look at your diagram, which I have passed out, but near the end of the 19th century, large discrepancies in the theory of an all-pervading ether began to appear. It's expected that light would travel with a fixed speed through the ether, but in that if you're traveling in the same direction as the light, it would appear slower, and if you're traveling in the opposite direction as the light, it would appear faster. This was not to be. A series of experiments failed to support that theory. The more accurate of these experiments was carried out by E. Morley and A. Michelson at the Case School of Applied Sciences in Cleveland, Ohio. What these 2 men did is they compared the speed of light in 2 beams at right angles to each other. As the Earth rotates on its axis towards the Sun, the apparatus should move through the ether with varying speed and direction. Yet Michelson and Morley discovered no such thing. What they saw showed as if light always traveled at the same speed relative to where one was, no matter how fast in one direction was moving. Here we have a bit of a charge. I probably should have printed this out. And what we're looking at is Galileo also tried to determine the speed of light, but without modern instruments, he was unsuccessful. He attempted to have two lanterns, one at his house and one in a field far away. And he stood in the field, and at his command, he had one of his servants um, basically open up the lantern, and he tried to time how long it took with a stopwatch. His final conclusion was that light is fast.
He was right.
That
Now-
guy was a genius.
I wonder how he got that.
And just by the way, the speed of light known is 299,792,458 miles per second.
The speed of light is fast.
It's not miles, it's meters.
Meters.
Yeah. It's 300,000 kilometers per second.
Ah, okay. It said M over S, so I said
Yeah.
it was miles.
It's meters.
Alright, this was first discovered-ish by a man by the name of Olaf Römer in 1676. Olaf Römer, in fact, investigated timings between Jupiter and its moons and the relationship with when Earth moves closer and farther, and was actually very close to the modern time. Now, here is another thing. The general theory of relativity, discovered by Albert Einstein in 1916, generalizes special relativity and Newton's law of universal gravitation. And
What
now,
does that mean? Taking the special theory and making it general.
basically, generalizing it makes it work for everything instead of just one simple equation, one simple distance. Now, special relativity is the physical theory of measurement in an inertial frame of reference, and it was first brought to light by Albert Einstein in his 1905 paper, on the electrodynamics of moving bodies.
The physical theory of measurement in an inertial frame of reference. What? You said this would be lighter. I'm
Carl
starting
said
No,
not to
I
believe.
said
Carl
that.
said it.
He
I'm
lied.
starting not to believe you, Carl.
If it's inert, what does that mean?
What? If it's inert, then it's inert. If it's inert, then it's harmless. It's
That-
not really doing anything.
That's part of it. That's part of it.
Inactive.
Yeah. It's time. I don't know.
I'm inert.
We'll come back to what this means. Alright, can you talk about the framework? Define that framework.
That basically means it's not moving, it's not changing at all. At least that's what I understood it to be. And it's basically, yeah. And then here we have Newton's law of universal gravitation. And his law of universal gravitation states that every point mass, basically every piece of something in the universe, attracts every other point mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the mass of the being.
So what he's saying is that the gravitation force between two objects in the universe is the product of both of their masses, and that the inverse of that is the square of the mass in between them.
You mean like mass, like more like distance, like area,
Distance.
like the stuff.
I think mass in the last line should be replacement. But that's disregard.
Alright.
We
Now-
don't know anything.
Now, just a few laws of motion. Newton's first law of motion, by the way, Newton was a genius. His first law of motion is that an object at rest stays at rest, and an object in motion stays in motion with the same speed unless acted upon by an unbalanced force, like friction, gravity, person, stuff like that. Now, Newton's second law of motion is that the acceleration of a body is directly proportional to, and in the same direction of, the net force acting on the body and inversely proportional to its mass. Thus, F equals ma,
Say what?
where F is the net force acting on the body. So net force, like how much power I put into the motion. And the net force essentially would also, since I threw it down, would be the sum of how hard I threw it and gravity pushing on it. And then M is the mass of the object, or how big this thing is, and how thick it is, and basically, if it was compacted into as much as it could, like ever, that's basically how it is. And A is the acceleration of the object, how fast it speeds up. Now, Newton's third law of motion is that when one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction to that of the first body. So, if I were to say push left, then left's body would, and as the motion states, automatically return that force to me. So that is how I would say push off of this wall. Now, this wall is heavy, so when I push on it, I can't push it anywhere. But the amount of force I push into it, if I keep adding force to that, eventually the force return will send me flying off. And how much time do you have?
About 3 minutes.
Alright, so I would stop here today. And
It says that.
any questions?
So does that thing of the sort of the energy and the going back, third law of motion, does that apply to the sort of thing that, say, I punch left in the face? Does that oblige him to punch me back in the face? Or is
Well,
that
if you
not
punched
the
him in the face, your face would kind of hurt. Because the force would be returned, essentially. And also because you just punched something.
Wait, why are we focusing then?
Yeah, why don't you focus on like that thing about the balloon filled with air and then you open up the end and it
He's
pushes
closer to
it.
me right now, so he's closer. If I were to
Pick up
lunge him-
Saul.
No, don't pick on them, pick on me.
Anything else?
The chair.
Why these two
Well, when we began this, working on these exhibitions, I had recently started watching some college-ish lectures on game theory with my mom, and I had just found that they were really interesting, and how it works was really, really cool, and I just wanted to investigate further. And astrophysics kind of built off my lit circles project, where a meteor hits the moon and knocks everything around, and well, I just thought it would be cool to investigate more on that too.
How would you apply your topics to the next question?
Game theory. Everyone's going crazy. There's no more food. You want to bomb someone and take all their food. Well, be careful. They might bomb you to death.
It becomes a much more sort of visceral,
Like-
felt experience than resource.
I gave a simple idea, but if you think about it, it happens every day. Do you provide financial aid to this country? Do you bomb these guys? Do you shoot at these guys? Should you kill this guy, or do we bomb this guy even if we're only 90% sure he's a terrorist? It gets to a lot more serious stuff.
When do you invest in the stock market? Yeah,
Other questions?
Yeah, I have a little question. Usually when there is the word theory, there is usually an author. So is there an author to game theory?
Economists.
A person who came up with that?
There would probably be. I forgot to put that in.
Somebody in particular. Is there a name or is it something that your mom came up with?
There would probably be a name. I think I saw it. I probably forgot to put it in.
Probably in the 1940s, but I'm could be. I don't know correctly.
All right, well, thank you very much for coming to Ryan's first exhibition.